I don't remember.
State machine.
What about, yeah, state machine, yeah.
Let me see.
ASMR is what I keep seeing.
And I'm used to it standing for, like assembly language, but like it used to be Microsoft assembly machine language or something, but that's not what it is here.
Yeah, it's algorithmic.
Algorithmic state machine. Got it. Okay, that makes sense. Okay. So I'm going to say our input is named X and our output is going to be Z. And we denote states. We're going to do states with a rectangle like that. And we have inputs will look like this. And outputs will look like this. And so for this particular state diagram, we'll start with the state S0, and that we'll say is our reset state. It doesn't have a reset on there, but it makes sense that that would be it. So I just decided that that would be it. And then from state 0, I want to look and see what my possible outputs are for my possible inputs. So my input is X. I just have the one input, it's X, and it could be either 0 or 1. And we see that if X equals 0, then we get that Z equals 0, and we would go to state S0. And if X equals 1, we see that Z equals 1, and we would go to state S1. So these are just kind of notes out there on the side. And so I have draw an arrow from here to my input. So my input looks like this. That's X. And I have two possibilities. I have 1. So 1 goes in this direction, and 0 goes in this direction, because my output, if I have 1, if X equals 1, my output is 1, and if X equals 0, my output is 0. And if X equals 0, I go back to state S0. And I also have
This is the class.
okay. So we'll hold on for a minute because I'm going to draw in my output Z here, and you'll see that I didn't put that in for the case where X equals 0, but it's going to come later. Okay, so all right, so I have that, and then this was if X equaled 1, then Z equaled 1, and we went to state S1. And then from S1, again, I can have X as my input.
It's weird how X is outside and past this state.
Yeah, it is.
That's what makes, I think that's what made it confusing when we first brought it up on the board. I was like, what am I looking at?
It's very confusing because
But-
it's not like your regular flow chart.
Yeah, but it's, I feel like once you see an example, it's not too hard.
It's not bad. I felt the same thing the first time I saw it. I had never done one, and I was in SI because I had not done one before. I'm like, oh, I can't do this. And then once I looked at it for a little bit, it's like, oh, okay, that's not so bad. Okay, so So here I have 0, and from S1, if my input is 0, I go back to S1, and my output is 1. Right. And so notice that, well, I'll wait till I get to the end, make sure. Okay, so then from S1, if x equals 0, then z equals 1, and we go to S1, and if x equals 1, z equals 0, and we go to S2. So notice from state S0, we had our input x. If x was 0, we went back to S0 and our output was 0. If x was 1, we went to state S1 and our output z was 1, and we have a symbol there for z. So from state S1, we have our input x. If our output is 0, then z is 1. I have my symbol for 1. If x is 1, then z is 0, so I don't put in my symbol for z. I can just go straight to S2.
That's weird.
Yes, that is weird. I had forgotten that.
Yeah.
So z showing up is output 1.
Yes. And then, so this is state S2. From S2, I have, if z is 1, my output is 1. So, I'm sorry, if x is 1. So here's x, and if it's 1, my output is 1, so I'll put a z, and my next state is S0. So I'll go all the way back up here. And join to that line. And if x is 0, my output is 0, and I go back to S2. So for this last one, if x equals 0, output equals 0, go to S2. If x equals 1, z equals 1, go to S0.
Does it matter like how you connect the lines to the state? Like, can you put it on the right side or does it have to
All the
close?
ones I've seen have been like, I tried to draw this one, so I did do that one on the side. I don't know, because like I said, I don't use those. Most of the ones I've seen look like the one on the next page, where you have things going just into the top and out of the bottom. There's,
I would assume you guys wouldn't get marked wrong for that.
I-
It's just the convention of drawing them.
yeah, I can't imagine you would.
Yeah, usually they would go like this was how it was on the PowerPoint, where you would like draw it so that it goes back to the little line.
Right,
You know?
So you combine the lines.
Yeah.
right.
But it matters.
Okay.
That's how I've usually seen them. Although the next one that I got, where it says convert this ASM chart to a state diagram, I got that from somewhere, a book or something, and it looks like they're not necessarily joining up with the other lines. But. Okay, so let's look at the next one. Oh, Did I skip? No, I just did it in a different order. Okay. Fully reduce the number of states and construct the reduced state table. So I did not do one that was incompletely specified before, so I thought I would do that here. And there are different possibilities. Not everybody will get the same answer because you can make different choices when you do an incompletely specified one. So, and he'll either tell you what to use, or, you know, you have different possibilities, and he'll have, you know, rubrics for grading the different possibilities. Okay, so I usually start with a way that would make it so that I have as many things the same as possible. So I would start by assuming both outputs 1. You could assume both 0, you could assume 0, 1, you could assume 1, 0. There's not a rule for that. But I'm going to assume they're both 1, and that gives me a whole bunch that'll be in the same group. Okay, so my original partition is everything. So A, B, C, D, E, F. Partition 1 is based on the outputs. So my possible outputs are 1, 0, 0, 1, 1, 1, and 0, 0. I don't have any 0, 0s. For 1, 0, I have A only. For 0, 1, I have B and F. And for 1, 1, I have C, D, E. So those will be my groups: A, B, F, and C, D, E. Okay, so now at this point, I would like to have as few states as possible. And so if I can, I will see, is there a way that I can set this up so that I don't have to break this up anymore? So I'll look at B. B has F and D. So B goes to F for W0. B goes to F for W0, and F goes to B for 0. All right, so that works. Don't have to split those up. C for W equals 0 is undefined. D goes to A. E goes to A. So I'm going to let C go to A as well. So that way I don't have to split them up. So for W equals 0, I decided that C would go to A. I could have chosen something different, but that would make my life harder. Now let's look at W equals 1. B goes to D, and F also goes to D. All right, so those are still good. C goes to E, D goes to E, and E, well, we can choose what we want, but we might as well let E go to E. And then everybody is in their own, everybody's good. I don't have to do anything else. So now I can make my minimized state table, and I'll have 3 states. I'll have A, B, and C. And then I have the next state. For W equals 0 and W equals 1. And I have my output for W equals 0 and W equals 1. Okay, for A, I see my next states were C and A, and those are still states that exist, so those are fine. And my outputs are 1 and 0. B, so it says F, but F is not one of my states anymore. So let's see, F was in the same group as B, so this will be B. And then when W equals 1, it was D. D is also not a state anymore. D is in the same group as C, so that would be C. And my output for B is 0, 1. And for C, what did we decide? C goes to A when W is 0, and C goes to E when W is 1, and the output is 1, 1.
But the E is combined.
Yeah.
Or
Oh, right. So what is E now? C?
C.
C.
I messed up on my homework because of that. The state tables that I haven't undefined.
All right.
Next state is confused.
Now we want to do a state diagram for this ASM chart. First, let's determine how many states are there.
3.
I see 3. Oh, it's a teeny tiny little, there we go. Okay, so we have 3, so I'll have T0, T1, and T2 are my states. So for T0, if my output is, if X is 0, if my input is 0, what's my next state? T0. And what's my output? 0. And for T0, if X is 1, what's my next state? T1. And what's my output? 0.
The what?
Because there's no symbol for an output, so the output is 0.
That's confusing.
So like since there's only one Z in the whole thing, you'll only have one output one.
Yep. All the rest are going to be output 0.
So then vice versa, like when you see that 1, you know you need a state Z.
Mm-hmm.
Like if you're drawing the chart from the diagram, like when you see that 1/1, you're gonna need a state.
Oh, yes,
Z.
correct. Yes,
Okay.
yes. I was confused about your question, but absolutely, yes. It's not, I was confused because you said state, but you meant output. Yeah.
Yeah.
Okay, so from T1, if our input is 0, if our input is 0, what is our output? T2. And what is, I'm sorry, I meant to say what is my next state, and also what is my output? 0. And from T1, if my input is 1, what is my next state?
T1.
T1. And what is my output? 0. And from T2, if my input is 0, what is my next state?
T0.
T0. And my output? 0. And from T1, if my input is 1, what is my next state?
So it goes to T1.
Yeah. Oops.
Are all of these milling machines? Like, is there a more example? Or is that even?
We're going to do that.
Ah,
Yeah.
okay.
So as 1 And what is our output?
A 1.
1. Okay, so for our next one, we're going to revisit the vending machine. Did y'all do this one in class?
We did for a while.
So it's,
Just for the lab, so y'all did not do this for, okay, you might do it in the next class then? What does it say in the syllabus? Our next classes are gotta be a review, he always does a review. Okay, all right, well, in previous years, he did this in class, like, with, an ASM, but that's, because this is slightly different from your lab. It only takes nickels and dimes. Okay, so consider a vending machine that accepts only nickels and dimes. It takes 15 cents to vend a piece of candy. If 20 cents is deposited, it credits the buyer with 5 cents and waits for a second purchase. Make a state diagram for a Moore type machine that illustrates this behavior. So let's think about what our states would be. And I'll start with S1, and we'll talk about how much money is in the machine and whether or not it dispenses candy. So I know I'm going to start off with S1, S2, and S3, and you can only put in one coin at a time. So I know I can start off with having 0, and these may look funny, but it's just so that I have them in the same order as my notes so that all my states will match up. So I don't know why I originally did a dime and then a nickel, but that's what I did. So I could have a 0 cents in the machine, I could have a dime in the machine, or I could have a nickel in the machine, and in none of those cases would I just have candy. So let's start with those. So I would say start with S1, and this is supposed to be a Moore machine, so it has a 0 because you're not outputting any candy. And I'm going to use as symbols D for saying you put in a dime, N for you put in a nickel, and D bar for not a dime, and N bar for not a nickel. Now notice the D, N together, the variable dn, that can equal 0, 0, 0, 1, or 1, 0, but it could never equal 1, 1 because you can only put in one coin at a time. So from state S1, if I don't put in a dime or a nickel, where am I going to go back to? Well, never, I kind of gave that away. All right, and then if I put in a dime and not a nickel, that will go to state S3. Actually, I had that over here. Not that it matters where it is, but I'm just trying to keep it similar. I'm just putting it in as nickel. I put in a nickel. And that would be S3. If I put in a dime, that would be S2. From either of these states, if I put in nothing, I'm going to stay where I am. All right, where should y'all go, where should we go from here?
For the dime, I mean, you split up into dime and nickel, because you're not at 15 for either one.
Say that again?
You split up into like, you can either get a dime or a nickel, because you're not at 15 yet.
Yeah, that's true.
Right. For S2 or S3?
For both.
Yes, right. Okay, I see what you're saying. Okay, yeah. So we're gonna say I'll have a dime and a nickel for each one of these. And they're gonna go to different states. And I think they're gonna be different states. Let's see. Okay, so if I add a dime to S2, then I'm going to go to what I'm going to call S5. And will that one have an output of something?
Yeah.
Yeah, that one will have an output. So I'm going to say S5 currently has 20 cents, and it will have an output of 1. I'm going to put 20/5 because it'll have 5 left over after it dispenses the candy. Then if I put in a nickel, I'm going to call that S4, and will that output something?
Yes.
Yes. So S4, and I'll call that 15/0 and 1. And then from S3, where I had 5 cents, if I put in 10,
You should go to the same state four.
it could do that. I'm not going to do that because we're going to pretend we don't see that, and then we're going to minimize this and see if it ends up that way.
Hmm?
We're going to pretend we don't realize this could be the same state as something else.
Right.
So I'm going to call this one the dime. I'm going to call that one S7. And I'll be 15/01.
I can't keep up with the descriptions. My head is
Well, you just follow the arrows. So it says the arrow has an end, says I got a nickel, and then from that one I got a dime. And then it says it's S7, so S7 I've got 15 cents. And then from having a nickel, I get another nickel, and I'm going to call that one S6. And that gives me 10 with an output of 0.
We're doing wound type, right?
Mm-hmm. And then from S4, no matter what, we're going to go back to S1, because from S4 we had no change left, so we're going to go back to that state. Am I just doing that no matter what, or did I not do this completely? I did not. Oh, I made it incomplete on purpose. Okay, so I said from S4, if I did nothing, I would go back to state S1, and I have like don't cares for the others. So I'm on purpose, I'm not specifying all of my outputs, because only some of them really matter. So let's see what else really matters. If I have from S6. S6 is important because I have 10 cents in there. So from S6, I could put in a dime or a nickel, and I would get S8 and S9. And those would both have an output. S8, I would have 20/5 with an output of 1, and S9, I would have 15/0 with an output of 1. And then for all the other states, I'm going to say if you do nothing, then you'll go back to the state that has that same amount of change, and I'm just going to leave the others unspecified. So for state S5, I had 5 cents change. Which one of these has 5 cents? What's that?
Which one are you looking at?
S3 has 5 cents.
S3 has 5 cents. So from S5, I'm just going to say no dime, no nickel. I'm going to go to S3. S8 also has 5 cents change, or does it have 0 cents change?
No, you're right. It was 20. Nickel, dime. For 20. Only get 5 cents.
Okay, so I have these, I did not label these right, but that's okay. So this is no dime, no nickel is going to go to S3. S9 has 0 cents change, so no dime, no nickel, that'll go to this one. And let's see, we have not taken care of S7 and S6 yet. So S6 has 0 cents change, so we could send it back to itself, or we could send it back. No, it has 10 cents, it's just waiting. So if we do nothing, it has to go back to itself. And S7 has 0 cents change, and so it would go back to the start.
With the change, is it like the vending machine where like you have to do a different cycle for the change given back, or?
It says it holds on to it for you to be able to make another purchase. So you have to.
Oh, credits the buyer.
Yeah.
Oh, okay.
So we had S1, S2, S3, S4, S5, S6, S7, S8, and S9. And we have our next state. And we have 4 possibilities: 0, 0, 0, 1, 1, 0, 1, 1. And I'm going to say these are in the order of DN. And our output Z. And it's a Moore machine, so the output depends just on the state. And so our 1, 1 column is all a bunch of not specifieds. Our output Z is 0, 0, 0, 1, 1, S6 is 0, and then 1, 1, 1. So S1, S2, S3 all go to themselves with 0, 0. S4, I think, went back to S1. S5 went to S3, S6 went to S6, S7 went to S1, S8 went to S3, and S9 went to S1. Does that match with what y'all have? Okay. And then for 0, 1, the only ones that we have this for, so this is if you put a nickel in, the only one that we had this for, we had, this would be S3, this would be S4, this would be S6, S6 would be S9. I think those are the only ones that we said what would happen if you put a nickel in. Y'all can check me on that and see if that's right. And then the only ones we said what would happen if we put a dime in are S1 we said would go to S2, S2 we said would go to S5, S3 we said would go to S7, and S6 we said would go to S8.
Don't care, or it's not possible, so.
What's that?
Yeah, for 1, it's not possible.
1, 1's not possible, yep. That's interesting.
Ooh.
I like that. That's not what I wanted. I want... Okay, so I'm going to call these I'm going to call these states and give them letter names because I like that better. So I'll call them A, B, C, D, E, F, G, H, and I. Okay, so now I'm going to fill this out, and I would say that for 0, 0, A goes to A. Of 0, 1, it goes to C. For 1, 0, it goes to B. And my output is going to be 0. And then for B, I have B, D, E, 0. C is CFG 0. And then I have A, C, F, H. Is that actually, I think these are backwards. I, H, 0. And these were 1s. And this is A, C, and 1, 1, 1. Okay. So our first partition will be A, B, C, D, E, F, G, H. And then we can break it up based on outputs. So I'll have A, B, C, F, D, E, G, H, I. And now I'll look at my 0 successors. A, B, C, and F all stay within the same group. So A goes to A, B goes to B, C goes to C, and F goes to F. That's all in the same group. For my 1, 0, A goes to C. Well, actually, let me check these others. So for D, E, G, H, I, those all go to A, B, C, F for 0. So then for 0, 1, I have A goes to C, but B goes to D, C goes to F, and F goes to I. So those got split up. These are a bunch of don't cares, so let's make them all go to the same thing. How about A? So then they can stay together. So now let's look at 1, 0. A goes to B and C goes to F, that's fine. B goes to E and F goes to I, so that's fine. No, F goes to H. Wait. B goes to E and F goes to H. Okay, so those are in the same group. And then D, E, G, H, I, those are a bunch of don't cares, so let's make those all A. And then our 1, 1s are all don't cares, so I can make them all A. And now we have minimized our state table. But it looks like I did it wrong. So I'm supposed to have 5 partitions. Yeah, I guess I have to go through it again. I think I need to check my A and C.
Now that A and, what is it, F are split up? Or like A and C and B and F, like the right side should all just split up there.
Yeah. So let's see. A goes to A and C goes to C. A goes to C and C goes to F. Yeah, okay, so A and C have to split up. B goes to D, and F goes to I, and B goes to E, and F goes to H. I think they can stay together.
I'm confused. How do you minimize? How do you do the partition with the multiple?
You do them one at a time. So you do the 0, 0, then you do the 0, 1, then you do the 1, 0, then you do the 1, 1. So this one was my output, and then this one was my 0, 0, and then I thought I had checked 0, 1, but I don't think I had. I think that's what I'm doing right now. So D, E. I need to go back and check my, okay, I did check them. They were all correct for 1, 0, and 1, 1, but now I have to go back and check my 0, 0 again. So D and E are now going to different places. So D is going to A, and E is going to C, and G is going to A, and H is going to A, and I is going to C.
It's definitely more complicated with.
It is. So now we have minimized it. And so our minimal state table is A, B, C, D, E. And then for 0, 0, we have A, B, C, D goes to A, and E goes to C. And 0, 1, we have C, D, and B, and these are don't cares, or you can put in A. And 1, 0 is B, E, D. 1, 1 is don't cares. And output is 0, 0, 0, 1, 1. Time 4:39. Okay, do y'all want to do the mealy? It's shorter, it has fewer states, or do you want to do the well, so this the state diagram for the reduced one would look like this, and we can get the mealy from the reduced state diagram. So let's see how we're going to do that. So here's our reduced state diagram.
That's pretty cool.
I'm going to go actually.
So just to recap, the minimization, when you take the partition, you just take the 0, 0 next state column, just that by itself,
Mm-hmm.
and then after you go through that, then you go through the next set of inputs, and then the next set of inputs.
Yes.
Okay.
I may have one state, like one of these backwards, because I originally had S8 and S9 swapped, and so I could have one of these wrong.
Yeah, I couldn't reduce because all of them are separate. But I started off with 5 states.
Oh, well, then you have the same thing. So 5 states is the way to go. Okay, so 5 states is correct, and these correspond to A as if you're at your reset, B as if you've put in a nickel, C as if you've put in a dime, and then D is
Dispense.
15 and E is 20, I think. Yeah. Okay, so let's now change this to mealy.
I think that's what it's matched.
So for mealy, we can say A is the state in which you have 0 cents. B is the state in which you have 5 cents. This is not an output. I'm just describing them right here. And C is the state in which you have 10 cents. And then your output will be on the arrow. So from A, if I have 0, 0, I go back to A and my output is 0. From A, if I have, what did I say came first? Dime? DN? Yeah. So if I put in 0, 1, so no dime but a nickel, I'll go to B. If I put in 1, 0, I'll go to C. From B, if I put in 0, 0, I'll stay in B. If I put in 0, 1, I'll go to C. If I put in a dime, I'll go back to A, so that'd be 1, 0, output 1. From C, if I put in 0, 0, I stay here. If I put in 5 cents, I'll go back to A, so that'd be 0, 1, output 1.
Because the dispensing thing is the output, so you get rid of 2 states.
Exactly. And if I put in a dime, then I will go to B, so that would be 1, 0, output 1. So we just have 3 states for the mealy machine.
Some people were trying to do the mealy for the elevator project. That just made my brain hurt thinking about it.
Were they successful?
They switched to more.
Oh, okay.
Yeah, they switched to more.
Yeah, I wouldn't want to try to do that. I just don't know how your outputs would work. I just don't think they would.
It's just too much.
Yeah. Okay, so I can do, I have an ASM chart for both of them, but I really only have time to do one. So let's do the ASM for the mealy because that one's only has the 3 states, so it'll be easier. Okay, so our states are A, B, and C, but notice that, well, I guess it doesn't really matter what order I put them in. So I'll put reset up here at top, and I'll have reset go down to A. And then I have two possible inputs. So I'm going to put them both here. I'll put a D, and I'll put an N. From the N, I go to state B, if N is 1. If N is 0, I go back to reset. If D is 0, then I check to see what N is. If D is 1, then I have something crazy looking here. What did I say? I said I went... Oh, okay.
Oh, how,
I'll show you. Okay, so if D is 1, I'm going to hold off on what we're going to do there for right now. So from, oh, wait a minute. I think this was states. Oh, I called these something different from before. That's okay. All right. And then from state B, we also have two possible inputs. We have a D and an N. We know that we're never going to have 1, 1. So we're never going to have the possibility that we're going to go get a 1 on D and then get a 1 on N. So the 0 line from the D is always going straight to the N to check to see what the N is. Now from state B, where I had 5 cents, I had a nickel. If I get a 1 on my dime, I have 15 cents. That means I get an output, and I go back to my reset. If I get a 0, I just go on to my nickel. If from my nickel I have a 0, I'm going back to, actually not there, to
back to B?
yeah, but for some reason you do it like that. Okay, and then from my nickel here, so I had, let's see, what do I have now? I had 5 cents, I didn't get a dime. Now if I get a nickel, I now have 10 cents. And that's the same as state C. So that's if I had a 1 there. So what happened if I got a dime is the same as if I get 2 nickels. And then, so now this is having 10 cents. So again, I'll check for a dime. If I get a 0 on a dime, I'll check for a nickel. I had 10 cents. If I get a dime, I now have 20. I'm going to get an output. So I'll get my Z. And I'm going to go back to my state of having a nickel. Right there. If I have 10 cents and I get a nickel, now I have 15 cents. That's the same as that. If I have a nickel and I get a 0, where am I? I had 10 cents. I'm back to having 10 cents. So I come back here.
I'm not sure how I feel about these.
Well, I agree with you. I remember now doing this. I'm so glad. I don't know. I must have realized I've scanned this and saved it on my computer because I've actually only done this one other time. I told you it's like every few years. It's only been one other time that I've actually done a session with it where I felt comfortable enough to do it. But I remember like staying up like hours and hours to make sure I got this right. And it doesn't seem like it should be that hard. It's not hard to read, really, but it's weird. So, all right.
Different.
Yep. Okay, so any questions before I shut down? All right.
No, thank you.
You're welcome.
And then maybe around Monday next week.
Mm-hmm.
Sounds good.
Yep. Do you have any exams on Monday?